In this video, we're going to look at solving cubic equations when we've been given all the linear factors, or perhaps we've just got a cubic and we need to work out strategies for the best way to solve that. If you've been given the linear factors of a cubic and you've been asked to solve it, so let's just make it an example up. If I've got x plus 2, x minus 1 and x plus 3 is equal to 0, and I've been asked to solve this, we can simply use the null factor law to solve this. You can use the null factor law beyond quadratics. You can use it for quartics or anything as long as you've got all the linear factors. So what we say here, using the null factor law, either x plus 2 equals 0, or x minus 1 equals 0, or x plus 3 equals 0. So solving those, x equals negative 2, x equals 1, or x equals negative 3. Now let's look at a case where we haven't been given the cubic in factorised form and we need to solve that. Let me just clear some space. So let's look at this first equation here. We've got to solve this one. Now looking at that equation, I've got every term on the left hand side has an x as a factor. So the first thing I'm going to do is pull out x as a factor, which leaves me with a quadratic in the bracket, like so. That then means all I've got to do is factorise the quadratic if it factorises. Now looking at that, I can see I can do factorising by grouping because I can multiply the a and the c together, minus 2, and I can think of two factors that also add together to make the minus 1. So if I do that, I get 2x squared minus 2x plus x minus the 1 equals 0. Hold on a sec. Alright, so now I can, just focusing on this, I can factorise this by grouping. So both of these, let's look at this first pair first. I can pull out a 2x as a factor within these two pairs, and I get x minus 1. And if I look at these two pairs, I've got plus the 1, and then obviously x minus 1 is the factor. Now I can group that. We can say that both these two terms have the same factor of x minus 1. So we can then say that 2x plus the 1 is multiplied by x minus 1. Now what I've done there is I've factorised, I'll just move out of the way, I've actually factorised the quadratic, and I've got a factor on the x, on the outside, which is x. I can now use the null factor law to solve this. So solving gives us either x equals 0 or 2x plus 1 equals 0, which solves to give us 2x equals minus 1, x equals minus 1/2. And then finally this one, either x minus 1 equals 0, solving to give us x equals 1. So there's our three solutions to this cubic. Looking at this one now, I've got to identify the fact there's also an x that I can pull out in all three terms. If I do the same thing as I did in this example, I'm also left with a quadratic. So let me just concentrate on what I'm doing. So I'm pulling out the x, and I've got minus 10. There we go. Now looking at this, does it factorise? Minus 10 and 1 factors of minus 10 add together to make 2. Not going to factorise. So I'm going to have to do something else. Could use a quadratic formula, or I could complete the square. So I'm going to complete the square of this. Now completing the square of this leaves me with, now you're going to have to remind yourself of how you complete the square, because I'm going to do this quite quickly, but don't forget when you complete the square, you're adding half the coefficient of the b to both sides. I don't technically have two sides within this because I've just got this single quadratic here, so you need to think a little bit outside the box. So when I complete the square of this, I get minus the 1 minus 10. Okay, so obviously I've thought to myself, I'm going to be adding that 1 to both sides, and what will happen to the 10 on the other side. So altogether, simplifying this gives me minus 11. So let's just write this. I've got x plus 1 squared minus 11 equals 0. All right, now that's now completed the square. I can now use the difference of two squares. If I write this as a square, which would be minus root 11 squared. So let's do that. X plus 1, so there's my difference of two squares, that would be my a squared, minus root 11 squared, which of course is minus 11, really. And that's my second term, so that's my b squared. Now I can write that as the difference of two squares, so it's in factorised form. So I get x plus 1 plus root 11 multiplied by x plus 1 minus root 11 equals 0. Now because it's factorised, doesn't matter that they're not whole numbers, I can now use the null factor law to solve that. So either x equals 0 or x plus 1 plus root 11 equals 0. Moving that across, x equals minus root 11 minus 1, or using this one, x plus 1 minus root 11 equals 0. I'm left with x equals, and I'm just going off the screen here, so apologies for that, but x equals, let me see, x equals plus root 11 minus 1.